Alright guys, so today we are going to cover label encoder. So a label encoder is a tool in machine learning that helps convert categorical data like words or label into numbers so that the data can be understood and processed by the machine learning algorithms. Machine learning algorithms model works with numbers, not words, because as our computers are good at understanding numbers and not words. So label encoding is the way to translate those words into numerical format. So let's get into the coding section. Alright, so let's jump into it. Label encoder assigns a unique number to each unique category or label in your data. So imagine you have a list of fruits in a dataset and you want to convert these fruit names into numbers so that a machine learning model can understand and use them. So here, as you can see, apple might be converted to 0, a banana might be converted to 1, cherry might be converted to 2, and I have created this list of fruit names. So it's particularly handy when the categories don't have an inherent order or when the order doesn't matter. However, label encoding can introduce unintended orderings if not used carefully, especially when the categories are not ordinal, meaning they do not have meaningful order. So let's go through this example. So as you can see, I have imported this label encoders from my sklearn preprocessing library. And then this is my original list of fruits. And I have initialized the label encoder by naming it as label underscore encoder. And then finally, we are doing fit and transform the fruit list by naming it as encoded fruits. And then once we print this and run this program, our fruit names are now converted into numerics. One thing to watch here is unintended ordinal relationships. So if the categories do not have a meaningful order, like apple, banana, and cherry, but you use label encoding and the model mistakenly might interpret banana, which is here 1, and it will interpret between the apple and cherry, which is 0 and 2, and this can lead to incorrect model assumptions, especially for algorithms like linear regression or logistic regression. So one workaround around this method is using one-hot encoding, which we are going to see into our next video. So the previous example has definitely gained you some knowledge of the label encoders, but then here we are going to implement based on the real life example. And in this case, I'm going to make use of a credit risk example. So credit risk model aim to predict whether a borrower will default on a loan based on various features. These features often include both numerical data like credit score or loan amount and categorical data like loan type or marital status. So here, as you can see, I'm importing this label encoder from our sklearn preprocessing library, and then of course importing this panda SPD, and then I have created this data set based on the different credit scores. Then I have created this income list within this data, and here are the different incomes, which is $60,000, $75,000, $80,000, and so on. And then as you can see here, my loan type, marital status, and employment type has the categorical data. So we have identified all this as categorical data. So what we are going to do is we are actually going to convert this into a data frame, and it's actually a pd.data frame. It's a constructor function in pandas that creates a data frame. And data frame is a two-dimensional tabular structure similar to a table in a database or an Excel spreadsheet. It has rows and columns, which each column can have different data types based on whether it's integer, floats, or strings. And once we have this, I'm just going to quickly run this and then quickly run this as well. And then we are going to name it as label underscore encoder and initialize with the label encoder with those parentheses. And once we have this data, so what we can do is we can apply label encoding to all our categorical columns. So how we do this, we are going to do df, and then in my square bracket, that's my name, loan type, which I have given into my previous, and then I'm gonna do label encoder. We're going to fit and transform this df loan type. So I'm just gonna copy paste for the rest of those categorical data. All right, so now let's print our data frame and see what we have got. All right, so this is perfect. As you can see, we have successfully converted our categorical data into different numbers. And you may ask me a question, why use label encoding in credit risk models? Well, there are three important reasons, which I think, which is ease of integration. So what do I mean by that? So what do I mean by that is many machine learning models require all input data to be numerical. So label encoding facilitates this by converting categorical data into numbers. Second, I will say it's model compatibility. So big algorithms like decision trees, random forest, and gradient boosting machines can handle numerical labels effectively without assuming any ordinal relationships. So that's the second most advantage. And then I would say is going to be a improved prediction. So in this case, by transforming categorical data into numerical format, the model can learn patterns that correlate with the loan default risk. That's it for today, guys. So into our next video, we are going to cover one hot encoding. Please like and subscribe to Goldfinch AI. We are going to make a projects on machine learning, deep learning, and large language models. Thank you so much for watching.